All right, let's jump right in. Welcome to this explainer. Today, we're going to put on the hat of an expert fund manager to really evaluate the massive, honestly unprecedented capital expenditure we're seeing across the tech sector right now. We are looking directly at the financial impact of AI infrastructure on public market investors. It's essentially a grand game of high-stakes chess playing out in real time, and we're going to break down the actual economics behind it.
Okay, so let's dive into this. The central question on literally every investor's mind right now is whether the current volatility and the massive spending we're seeing in tech is just another bubble, or if we're looking at a fundamental long-term economic shift. Our goal here is to completely separate the short-term hype from sustainable long-term cash flow growth.
Here is our roadmap for this explainer. Think of this as our investment memo. We're going to start with the core thesis, analyze the hardware advantage, look at big tech's actual returns, explore Main Street productivity, and finally, we'll stress test this whole idea by evaluating the legitimate risks.
Okay, Section 1, the AI Infrastructure Thesis, separating hype from sustainable cash flow.
Look, to really understand what's happening out there, we have to tune out the Twitter vibes and look strictly at empirical financial data. There is a ton of debate going around about the ROI on all this AI spending. But if you look at the audited quarterly financials of the absolute largest public spenders on GPUs, the data tells an incredibly clear story. If you calculate the return on invested capital, or ROIC, for these massive companies today, it is empirically, factually higher than it was before they ramped up their AI spending. The returns are actually there.
Moving right along to Section 2, the Blackwell competitive advantage, winning the low-cost token war. So right now, being the low-cost producer of tokens is the single defining competitive advantage in the AI space. Think about Nvidia's older Hopper chips, or even current TPUs. They're kind of like a highly tuned P51 Mustang, or an F4 Phantom from the past. I mean, they're great for their time, highly optimized by engineers, but fundamentally, they're aging technology. The new Blackwell architecture, especially the GB300, is like an F-35 stealth fighter. Going from traditional air-cooled racks to incredibly dense liquid-cooled racks is easily the most complex product transition in tech history. You literally need a plumbing degree to run a server room now. But here's the payoff. It radically changes the cost structure, delivering a massive, decisive per-token cost advantage for whoever deploys it first. And that brings us to the competitive landscape. Honestly, there are really only 4 labs that matter right now. First, you've got xAI. They are building data centers faster than anyone else on Earth and are perfectly positioned to train the very first Blackwell model. Then there's Google. They currently hold a temporary advantage as the low-cost producer using their internal TPUs, which basically allows them to suck the economic oxygen out of the room by running at lower margins. But that advantage definitely fades once Blackwell scales up. Then we look at OpenAI. They are currently paying margins for external compute, which puts them at a severe, high-cost disadvantage. It's a huge part of the reason for their recent massive funding rounds. And finally, Anthropic. They're playing a really smart game, partnering with Google and Amazon while also securing a massive $5 billion deal directly with Nvidia. Make no mistake, the changing economics of these chips absolutely dictates who wins this foundational race.
All right, Section 3, Big Tech Revenue and ROI. Turning AI spending into operational efficiency.
Let's shift our focus to the internet giants for a second and see how this all builds into a very straightforward linear equation inside big tech. Step 1, these companies take their massive recommender systems, the algorithms that power all the advertising and content feeds, and they move them from traditional CPUs over to GPUs. Step 2, this creates just enormous efficiency gains in ad targeting. And step 3, this directly accelerates their overall top-line revenue growth. It's a surprisingly simple formula. Give the engineers more GPUs, and it directly drives higher efficiency and increased gross profit.
But wait, there is a catch. As an investor, you have to navigate what we call the ROI air gap. Right now, a massive amount of capital is tied up in simply training these frontier models, like the very first models running on Blackwell. And here's the thing, there is absolutely zero immediate ROI on training. The real financial return, the actual cash flow, doesn't hit until those models are finished and they shift over to the inference phase, which is when they're actually being used by consumers and businesses to generate answers. Navigating this temporary gap without panicking is absolutely crucial for anyone in the public markets right now. Which leads us to Section 4, Fortune 500 productivity gains, Main Street's measurable ROI. Let's step outside the Silicon Valley bubble for a minute. Are traditional non-tech enterprise companies actually applying this technology today in a way that matters? The answer is a resounding yes. Just recently, the stock of C.H. Robinson, which is a massive freight forwarding company, jumped nearly 20% on their earnings. And the wild thing? That jump was purely driven by AI productivity uplifts.
To put that into perspective, let's look at their operational breakdown. Before they implemented AI, when a customer urgently needed trucks, C.H. Robinson could only manage to quote about 60% of inbound requests, and it was taking them anywhere from 15 to 45 minutes just to generate a single quote. By integrating AI, they are now quoting 100% of inbound freight requests, and they're doing it in mere seconds. I mean, this directly impacts both their top-line revenue and their bottom-line costs. This is in theory, it is highly measurable, undeniable ROI happening right now on Main Street.
But while Main Street is reaping the benefits, there's a new reality for the broader software industry, and it's a number they kind of hate: 35 to 40%. This is the new, significantly lower gross margin reality that software companies simply have to embrace if they want to survive this AI transition.
Let's break that down. If you look at traditional software as a service, or SaaS companies, they are totally used to these cushy 80% gross margins. Why? Because they write the code once, and then they distribute it at basically zero marginal cost. AI is the exact opposite. You have to expend expensive compute power to generate an answer every single time someone uses it, which pushes those margins way down to 35 or 40%. Traditional SaaS companies that are stubbornly clinging to those 80% margins are literally repeating the exact same mistake brick-and-mortar retailers made when they laughed off e-commerce just because the shipping margins looked bad. AI-native companies operate at much lower gross margins, sure, but because they require drastically fewer human employees for sales and support, they actually end up generating free cash flow much, much faster.
Okay, finally, Section 5, Evaluating Hardware Demand Risks. What actually breaks the capacity cycle? As a fund manager, you always have to stress test your thesis. So let's look at the legitimate threats, the bear case, for all this hardware demand. First up is Edge AI. Think about it. If Apple and others can run pruned-down models locally right there on your phone for free, and it satisfies basic daily needs at 30 to 60 tokens a second, well, that drastically reduces the demand for massive cloud inference. Second, you have capacity bottlenecks. We're talking specifically about Taiwan Semi, who remain deeply, historically paranoid about overbuilding their fabs. Third, classic inventory gluts. The iron law of semiconductors basically states that eventually, supply always catches up to demand and causes a glut. And lastly, power constraints. Quite literally, the physical limits of wattage available for data centers on Earth acts as a natural governor on all this expansion. But here is the really crazy part about that last risk. If power is the absolute constraint, it actually massively benefits the most advanced hardware producers. If a company can only secure a strictly limited amount of wattage for a data center, the initial sticker price they pay for the compute hardware becomes totally irrelevant. The chip that generates the most tokens per watt is the undisputed winner. And that dynamic basically ensures that companies like Nvidia maintain immense pricing power for their most efficient, cutting-edge chips. To bring all of this together, I love this mental model from the incredible AI researcher Andrej Karpathy. He says, with software, anything you can specify, you can automate. With AI, anything you can verify, you can automate. Whether it's balancing an accounting book, driving a successful sales conversion, or quoting a freight route in seconds, if the final outcome can be verified, AI can be trained to do it. This is exactly how you should be evaluating any company's AI ROI potential moving forward. Which leaves us with one final provocative thought. If the iron laws of economics dictate that every historical shortage is eventually, inevitably followed by a glut, are you actually positioned for the inevitable AI hardware capacity cycle? Understanding this infrastructure thesis isn't just about blindly riding the hype waves today, it's about really knowing how the board is being set up for tomorrow. Thank you so much for joining me on this explainer. Keep analyzing, keep questioning, and I'll see you next time.